A big move by China to restrict exports of some metals widely used in semiconductors, electric vehicles and high-tech industries has ramped up a tech war with the United States and could potentially cause more disruption to global supply chains.
The struggle over semiconductors just got more intense. China is curbing exports of key metals needed for chips.
On the heels of a seismic political shift in the United States, newly elected President Donald Trump took a decisive and controversial step by imposing sweeping tariffs on America's key trade partners. Among those most significantly affected was China, long a pivotal player in the global supply chain and the US's largest trading partner. These tariffs, billed as part of a broader economic strategy to revitalize American manufacturing and reduce reliance on foreign goods, were immediately met with fierce international scrutiny. But perhaps the most consequential response came not in the form of rhetoric, but in action, from Beijing itself. Before we start, smash the like and subscribe buttons for more updates. China's countermeasure wasn't just a retaliatory tariff or a symbolic move. It was a strategic strike directly aimed at the Achilles heel of modern American technological dominance, the semiconductor industry. This industry, the lifeblood of everything from smartphones and defense systems to artificial intelligence and critical infrastructure, is deeply integrated with Chinese manufacturing and rare earth supply chains. By enacting a set of sweeping restrictions, controls, and disruptive regulatory changes, China initiated a calculated counterstrike intended to destabilize the entire U.S. semiconductor sector at its core. The move came swiftly and with precision. Almost overnight, China announced a complex framework of export controls on rare earth elements, specialized chemicals, and advanced chip-making equipment, components on which the U.S. semiconductor industry is heavily reliant. Rare earths, which China produces and refines in dominant global quantities, are essential in the manufacturing of not just semiconductors, but also high-performance electronics, electric vehicles, and defense systems. By choking access to these critical inputs, China aimed not only to halt immediate production cycles, but to send a chilling message through the corridors of American tech giants. Dominance cannot be sustained without cooperation. What made China's response particularly potent was its layered, systemic nature. It wasn't a headline-grabbing, one-time embargo, but a carefully architected disruption to the vast and intricate network that supports the design, manufacturing, and distribution of chips. Regulations were imposed on the licensing of exports, approval times were extended, and priority access was shifted to domestic Chinese firms. American companies, many of whom had spent decades optimizing their supply chains with Chinese partnerships and suppliers, suddenly found themselves in a precarious position. Equipment orders were stalled. Chemical deliveries were rerouted or canceled outright. Fabrication timelines extended from weeks to months as key inputs vanished from their predictable schedules. For semiconductor companies based in Silicon Valley and beyond, the implications were staggering. Firms like Intel, NVIDIA, AMD, and countless others depend on uninterrupted flows of highly specialized components to keep up with the unrelenting pace of innovation. In an industry where obsolescence can set in within months, any production delay is tantamount to a strategic setback. The Chinese moved through these timelines into chaos. Products scheduled for release were postponed indefinitely. Research and development projects were put on hold, and investor confidence began to tremble under the weight of uncertainty. Beyond the immediate operational disruption, China's counterstrike also exposed a deeper vulnerability in America's technological infrastructure, its dependence on foreign resources for even the most critical of innovations. While the United States leads in chip design and intellectual property, the actual production process is an international relay race involving dozens of countries. Foundries in Taiwan, testing in Southeast Asia, and material supplies from China form the unseen backbone of every microchip etched onto a silicon wafer. By targeting a key leg of this relay, material input, China undermined the entire structure with one swift blow. Compounding the pressure was China's simultaneous push to accelerate its own domestic semiconductor capabilities. While the US was reeling from sudden shortages, Beijing funneled unprecedented amounts of capital into its chip design and fabrication industries. Incentives were expanded, new fabrication plants were announced, and existing companies were mandated to decouple from US dependencies. This wasn't merely a response, it was a pivot to dominance. With the American industry scrambling for alternatives, Chinese firms seized the opportunity to fill the vacuum, not just domestically, but in emerging markets where cost and accessibility often override allegiance to geopolitical alignments. This strategic duality, cripple the opponent while strengthening the self, had reverberations well beyond the balance sheets of tech corporations. It raised existential questions for policymakers, defense analysts, and economists alike. The US military, for instance, relies heavily on semiconductors for precision weaponry, satellites, radar systems, and secure communications. Any sustained disruption in chip availability directly affects national security preparedness. Meanwhile, consumer industries, from smartphones to automobiles, faced spiraling costs and production backlogs, setting off inflationary pressures that could ripple through the broader economy. Financial markets responded with turbulence. Tech-heavy indices showed immediate declines, with semiconductor firms bearing the brunt of the volatility. Analysts scrambled to revise forecasts. CEOs issued damage control statements, and industry lobbyists intensified their efforts in Washington. The strategic nature of China's move made it clear that this was not just a commercial disagreement, it was an economic battlefield where the rules of engagement had fundamentally changed. Yet the complexity of the situation made retaliation difficult for the United States. Any reciprocal action risked further entrenching the divide and causing long-term damage to global supply chains. American manufacturers could explore alternatives, sourcing rare earths from Africa or South America, for example, but building the infrastructure to match China's scale would take years, not months. Some pushed for immediate federal subsidies to boost domestic chip manufacturing, but such efforts were already playing catch-up against China's head start and resource dominance. In the broader context of global geopolitics, China's move was seen as a harbinger of a new era, one where economic interdependence could be wielded as a weapon. The notion that globalization was a buffer against conflict was shaken. Beijing's strategy signaled that when the stakes are high enough, even deeply integrated economies can be turned into instruments of leverage. In doing so, China not only challenged the United States' economic position, but also its assumptions about the limits of state-driven retaliation. Global allies and trade partners watched nervously. Countries in the European Union, Southeast Asia, and beyond understood the stakes involved. They were faced with difficult choices: align with one superpower at the cost of alienating the other, or attempt to navigate an increasingly fractured global order. In some quarters, China's move was seen as a warning shot. Dissent against its economic interests could carry tangible consequences. In others, it was a wake-up call to diversify and de-risk national supply chains before similar vulnerabilities could be exploited. Multinational corporations, particularly those operating in both the US and China, found themselves caught in an impossible balancing act. Some began shifting assembly operations to other Asian countries, hoping to avoid the direct fallout. Others explored joint ventures with local Chinese firms to retain access to critical materials and components. But the overarching challenge remained: how to operate in an environment where political decisions could trigger systemic supply chain failures overnight. China's counterstrike was also symbolic in nature. For decades, the narrative surrounding Chinese manufacturing had been one of dependence and lower-tier participation in the value chain. This move flipped the narrative. By showcasing control over key materials and the willingness to wield that control, China repositioned itself not as a participant, but as a gatekeeper. And for the United States, that shift forced a fundamental reassessment of what economic sovereignty truly meant in a world so intricately connected by trade and technology. The timing of the counterstrike was also strategic. Occurring in the early days of the Trump administration, it served to test the mettle of the new leadership while exploiting the transitional chaos that often accompanies a shift in power. It also complicated any hope of a quick diplomatic reset, as both nations now had skin in a high-stakes standoff with global implications. The nature of the semiconductor industry, unforgiving, fast-paced, and capital-intensive, meant that delays and disruptions would have a long tail, affecting innovation cycles for years to come. While tariffs are often used as blunt instruments to rebalance trade deficits or protect domestic industries, China's surgical strike revealed just how asymmetrical global economic warfare had become. In targeting a sector so vital, so complex, and so irreplaceable, Beijing didn't just retaliate, it redefined the terms of engagement. And in doing so, it laid bare the vulnerability of even the most advanced economies when interdependence is taken for granted. As the US semiconductor industry scrambled to assess the full scale of the disruption, a broader truth emerged. The next frontier of global power isn't just about who holds the most patents or produces the fastest chips. It's about who controls the pathways that make such innovations possible in the first place. The material inputs, the refining capacity, the regulatory frameworks, all of these are as critical as the end products themselves. And in this particular confrontation, China demonstrated that it holds more of those cards than many had realized. The psychological impact was no less significant. Boardrooms across America were forced into crisis mode, not only to manage the logistical fallout, but to reconsider fundamental assumptions about global operations. Risk management now included geopolitical forecasting. Business continuity planning now required contingency for resource nationalism. The semiconductor supply chain, once an emblem of global collaboration, was now a potential fault line in the geopolitical tectonics of the 21st century. In many ways, the Counterstrike marked the emergence of a new kind of arms race, not of missiles and warships, but of chips and materials, of access and denial, of infrastructure and autonomy. It raised the stakes for both countries, turning what was once a dispute over tariffs into a structural contest over the very architecture of modern life. From artificial intelligence to quantum computing, from 5G to space systems, every sector that relies on advanced semiconductors now found itself caught in the crossfire of a conflict that had only just begun. This was not merely a flashpoint, it was a pivot, a moment that forced the world's largest economies to reckon with the vulnerabilities they had built into their own systems. And while the immediate effects were felt most acutely in American tech corridors, the ripples spread outward, touching every part of the global economy that depends on the invisible yet indispensable power of semiconductors. The aftershock of China's strategic blow to the US semiconductor industry didn't unfold in isolation. It initiated a domino effect that swept across international supply chains, diplomatic relations, and industrial strategies in a wave of recalibration. Though the immediate target was the American tech sector, the implications extended far beyond. The deliberate precision with which Beijing executed its plan revealed deep foresight and long-term vision, marking the action not just as a reprisal, but as a calculated gambit to reshape the global technological order. As Chinese ministries enforced stringent licensing policies on exports of rare earth materials and critical processing chemicals, a ripple of disruption surged through logistical networks. Port schedules were thrown into disarray as containers packed with restricted materials were halted for additional scrutiny or outright confiscation. Warehouses across Southeast Asia and the US found themselves with half-filled inventories, their production lines starved of elements necessary for even the most basic manufacturing processes. The dominoes tipped further as downstream industries, those reliant on components built with semiconductors, were suddenly thrust into contingency planning, desperately seeking workarounds to bridge the supply void. This interference exposed a harsh truth about the rigidity of the semiconductor ecosystem. Its structure is not designed to withstand sudden shocks. It thrives on predictability, lean inventory models, just-in-time deliveries, and seamless coordination across continents. Disruptions in even a single node, let alone multiple, as engineered by China's maneuver, can paralyze the entire system. For American producers, this meant that even the largest and most resourceful companies were powerless in the face of a well-timed bottleneck. The depth of the disruption also illuminated the strategic interweaving of China's industrial policies with its geopolitical objectives. Unlike traditional retaliatory measures, which are often reactive and visible, this was a premeditated long-game tactic embedded within years of state planning. Beijing had, for over a decade, been tightening its grip on rare earth production, investing heavily in mining operations, processing facilities, and refining capabilities while simultaneously disincentivizing foreign reliance through selective partnerships and domestic prioritization. That foundation provided the muscle for this moment. By holding the reins of such a critical resource and controlling every step from extraction to final processing, China ensured that any attempt to bypass its system would face not only economic friction, but a formidable technical barrier. Western countries may have reserves of rare earths, but few possess the refining infrastructure or the environmental latitude to process them at scale. Attempts to develop alternative sources would require not just investment, but time, an asset not readily available in a market that evolves on 6-month design cycles. This asymmetry forced U.S. industry leaders into a rapid pivot. Previously offshored processes were now reevaluated through the lens of national security. Cleanroom facilities, foundry partnerships, and advanced material processing centers were proposed or fast-tracked on American soil. Yet such efforts, though ambitious, faced an uphill battle. The skills pipeline for high-end chip manufacturing in the U.S. had long been neglected, and the expertise required to replicate the precision of Asian foundries was not something that could be cultivated overnight. Even within the U.S. government, the situation exposed fractures in preparedness. The federal response machinery, often calibrated for conventional economic policy, was unfit for navigating a techno-industrial siege of this magnitude. Interagency meetings were convened at breakneck pace, with representatives from the Departments of Commerce, Defense, and Energy scrambling to map the real-time fallout. Intelligence assessments poured in, each underscoring the severity of the situation. Economic analysts issued grim projections, while defense strategists flagged critical delays in next-generation radar and surveillance system production. Amid the internal frenzy, external stakeholders began reassessing their alignments. European nations, caught between the gravitational pulls of Washington and Beijing, faced stark questions about the security of their own supply chains. The German auto industry, heavily dependent on American semiconductors and Chinese raw materials, faced production standstills. French aerospace companies warned of cascading delays in satellite deployment. In response, European Union policymakers initiated emergency sessions to explore the feasibility of a continental semiconductor initiative, one that could buffer the region from future superpower skirmishes. Meanwhile, Japan and South Korea, both tech powerhouses in their own right, confronted their own strategic calculus. Their fabrication facilities, often contracted by American firms, suddenly found themselves squeezed between two behemoths. As key links in the global semiconductor food chain, they were acutely aware that any misstep in diplomatic posture could incur a commercial penalty. South Korean conglomerates, for instance, began to stockpile rare earth inventories, even exploring black market options to sustain production. Japanese officials quietly opened dialogue with Australian and African suppliers, initiating talks to co-invest in non-Chinese processing plants. What unfolded was not merely a supply disruption, it was the unveiling of a new framework in international relations, where economic resilience became inseparable from strategic autonomy. No longer could nations afford to treat technology policy as a purely commercial domain. Every component, from the smallest capacitor to the most advanced microprocessor, was now a potential flashpoint in an invisible war. The timing of China's move also had a chilling effect on innovation pipelines. Research institutions and tech startups, traditionally the engines of progress, suddenly found their grant funding tied up in uncertainty. Venture capital firms, wary of the regulatory unknowns now surrounding component sourcing, pulled back on semiconductor-adjacent investments. Universities saw delays in collaborative research as key lab instruments, many containing restricted Chinese parts, were now subject to new compliance checks or outright bans. This stalling of innovation was perhaps the most insidious consequence of China's maneuver. The U.S. semiconductor industry doesn't thrive on what exists, it thrives on what comes next. A delay in research today equates to a delay in competitiveness tomorrow. By throttling the inputs that fuel experimentation and prototype testing, China wasn't just hampering present operations, it was freezing the future in place. Yet, perhaps the most profound implication was psychological. For decades, the U.S. had operated with a kind of technological invincibility, a belief that its innovation engine could outrun any threat. China's intervention shattered that illusion. It reminded American leaders, executives, and citizens alike that supremacy built on fragile interdependence is not supremacy at all. It's a house of silicon cards. In boardrooms across the U.S., risk officers began redrawing their maps of geopolitical exposure. Dual sourcing strategies gained traction. Emergency procurement protocols were rewritten. partnerships with second-tier suppliers in countries like Vietnam, India, and the Philippines surged, as companies sought to diversify their exposure. Yet, with every contingency plan came the hard truth. The cost of doing business had now permanently increased. Tech companies in particular faced an uncomfortable shift in messaging. Once champions of a borderless world, they now had to justify higher costs, longer lead times, and shifting product timelines to a consumer base that had grown accustomed to convenience. Shareholders were briefed not on growth strategies, but on containment policies. Brand equity was no longer tied only to innovation, but to resilience and adaptability. On the Chinese side, the response was equally strategic. Rather than resting on the success of its disruption, Beijing accelerated its internal semiconductor ambitions. National champions were buoyed with state grants, and new talent acquisition programs were launched to lure overseas engineers. Universities were directed to recalibrate their curriculums toward chip design and materials science. Even entertainment budgets were trimmed in favor of investments in computational infrastructure. In effect, China was transforming its retaliatory momentum into a foundational shift, an attempt to become not just a supply gatekeeper, but a global originator of semiconductor breakthroughs. This wasn't just about stopping the US, it was about leapfrogging it. Diplomatically, Beijing's gambit sent a stark message. Technological dependency carries political costs. In sidestepping traditional forms of retaliation like tariffs or sanctions, and instead wielding structural control over global production inputs, China had introduced a new kind of deterrence. It didn't need to fire a single shot or issue a single threat. It only had to turn a valve. The fallout also affected the software sector, which relies on continual hardware upgrades to support expanding functionalities. Cloud providers faced unexpected infrastructure delays, while AI companies saw training times for large models increase due to hardware shortages. Edge computing initiatives, dependent on the rollout of specialized chips, were shelved in favor of less ambitious deployments. Entire segments of the digital economy began to feel the pinch. Interestingly, this disruption also catalyzed new alliances. Latin American countries, long peripheral in semiconductor narratives, were now being courted for mineral resources and processing agreements. African nations with untapped rare earth deposits found themselves at the negotiating table with representatives from Washington, Tokyo, and Brussels. New shipping routes were proposed. Joint ventures were drafted. And though none of these alternatives could match China's current capabilities, the geopolitical map had begun to stretch in new directions. Perhaps most poignantly, China's maneuver forced a societal reckoning with the invisible complexity of modern life. Consumers, previously unaware of how deeply semiconductors pervaded their daily routines, now faced device shortages, higher prices, and delayed product launches. News cycles once dominated by political theater or cultural trends were now fixated on chip supply chains, bringing an esoteric topic to the forefront of public consciousness. Educational institutions also responded. Courses in supply chain management, international trade law, and semiconductor engineering saw spikes in enrollment. Think tanks published white papers at an unprecedented rate, attempting to parse the implications of a world where trade was no longer just commerce, but statecraft. By asserting its control at a pivotal moment, China had pulled back the curtain on the architecture of global power in the digital age. It was no longer enough to own the code or the intellectual property. True power lay in the scaffolding, the materials, the tools, the gatekeeping mechanisms. And in this realm, China had played its hand with extraordinary precision. The disruption may not have been permanent, but it was transformative. It recalibrated the ambitions of nations, the priorities of companies, and the assumptions of ordinary citizens. It marked the beginning of a world where the flows of sand and metal mattered as much as, if not more than, the flows of capital and code. It was a reminder that the future is not just built, it is supplied. And in the contest for who supplies the future, China had just made its boldest move yet. As the ramifications of China's calculated disruption to the US semiconductor industry deepened, a new paradigm began to assert itself in international affairs, one where technological assets became geopolitical currency. This was not simply a matter of industrial policy or global competition in commerce. It marked the transformation of semiconductors into instruments of statecraft, tools with the power to redraw alliances, shift military doctrines, and redefine national power. The full breadth of China's countermeasure became more apparent as the layers of impact unfurled across sectors not traditionally associated with semiconductors. In agriculture, for instance, the growing dependence on precision farming tools, powered by AI chips and sensor-laden platforms, was suddenly at risk. Tractors and drones, automated irrigation systems, and soil analysis devices that relied on embedded silicon were caught in an unexpected bottleneck. Agricultural productivity projections dipped, and logistical planners began to reconsider timelines for harvest and shipment. For a country like the United States, where agritech is integral to both domestic food security and global export strategy, the ripple effect carried weight well beyond the factory floor. The energy sector was not spared either, as renewable infrastructure, particularly solar, wind, and smart grid technologies, relies heavily on high-efficiency chips for monitoring, conversion, and optimization. The component shortages began to hinder deployment schedules. Projects funded under clean energy initiatives, whether federally or privately backed, now faced delivery uncertainties. Engineers recalculated performance models while procurement managers negotiated frantic, last-minute deals with secondary suppliers who were themselves uncertain of their ability to deliver. In the world of transportation, the blow was acutely felt in the electric vehicle EV market. Tesla, Rivian, and General Motors, all of which had set aggressive production targets, were forced into recalibration. EVs require an extraordinary amount of silicon-based components, from control units and powertrain management systems to entertainment consoles and autonomous driving features. Production lines slowed, software rollouts tied to specific hardware builds were postponed, consumer orders were delayed by months, and global marketing campaigns had to be amended to reflect new timelines. The automotive sector, which had spent the last decade racing toward technological sophistication, suddenly confronted a new reality: the fragility of progress in a hyper-connected supply chain. Within the financial sector, the reaction was equally intense but took a different form. Hedge funds and institutional investors reweighted portfolios based on a recalibrated risk matrix that now treated chip supply chains as volatile assets. Derivatives tied to tech performance were revalued. Sovereign wealth funds began to pull capital out of vulnerable semiconductor firms, redirecting resources into domestic infrastructure or defensive assets like rare earth mining operations. The shift was rapid and wide-reaching, underscoring how a disruption rooted in physical logistics could ricochet through intangible markets with unprecedented speed. Meanwhile, the legal implications of China's move began to surface. Trade lawyers and policy analysts were drawn into debates over the interpretation of WTO provisions concerning critical material control. While tariffs could be disputed under long-standing protocols, China's action involved a sovereign decision to limit the export of raw materials deemed strategic to national interest, a category that occupied murky legal ground. It wasn't a violation in the traditional sense, but rather a redefinition of sovereign rights under the veil of economic prudence. U.S. representatives began building arguments for emergency appeals, but the timeframes involved rendered these efforts more symbolic than actionable in the short term. In intelligence circles, the maneuver was seen as a masterclass in strategic patience. Reports indicated that China had likely modeled multiple retaliation scenarios well in advance, identifying precisely which materials and processes were most likely to inflict disproportionate damage with minimal international backlash. Unlike a cyber attack or a military exercise, which would trigger immediate and visible diplomatic outrage, China's move was technically legal, cloaked in commercial rationale, and devastatingly effective. Military planners began to reassess wargaming scenarios. Whereas previous exercises assumed that battlefield superiority was primarily determined by troop movement, air power, and logistical supply, a new layer emerged, one focused on technological attrition. If one side could deny the other access to advanced computing, real-time intelligence, or signal processing due to a chip shortage, the balance of power could tilt before a single shot was fired. Scenario models were updated to simulate the impact of prolonged chip unavailability on missile guidance systems, drone fleets, and naval radar. For the Pentagon, a new form of vulnerability had been unearthed, one not easily addressed with traditional doctrine. Amid all this, the media ecosystem underwent a subtle but significant transformation. Technology reporting, previously dominated by product launches and corporate earnings, shifted toward geopolitical analysis. Journalists embedded in the semiconductor beat found themselves thrust into primetime coverage as newsrooms scrambled to explain the sudden centrality of chips to everything from defense to grocery delivery. Phrases like lithography equipment, substrate shortage, and supply chain choke point entered public discourse with surprising ease as readers and viewers sought to understand how a retaliatory measure in China could delay their new phone, car, or laptop by months. If you like this video, please give it a like and subscribe to our channel. Also, leave your comments below and tell us. What are your thoughts on China's counterstrike? What do you expect will happen next? We want to hear from you. Thank you for watching and see you next time.